Welcome back to the Deep Dive. Our mission today is to take your stack of foundational accounting sources and really distill the absolute essence of cost analysis.
Mhm.
If you're a manager, a forecaster, or just someone prepping for a crucial meeting, you know that mastering your cost structure is everything.
It is.
But that goal often gets jammed up by one specific problem: the challenge of the mixed cost.
It's the most slippery creature in the cost menagerie, for sure. Mixed costs are those expenses that, they refuse to be labeled purely fixed, like that unavoidable monthly insurance payment,
Right.
or purely variable, like the steel in your product.
Hmm.
They always contain a little bit of both.
Okay, so like a maintenance department budget.
A perfect example, you have salaries for the supervisory crew, which are fixed, and then the spare parts that fluctuate dramatically based on machine usage.
And if you just leave that cost mixed up, you're paralyzed when it comes to predicting the future. If you tell your team to ramp up production by 30% next quarter, how much will your total costs jump? You can't budget, you can't price, you certainly can't calculate a reliable break-even point.
Precisely. The core requirement for any effective financial forecasting, specifically cost volume profit or CVP analysis, is decomposition.
Good.
We have to be able to split those mixed costs into their fixed and variable elements.
Okay?
That separation is the key to creating a linear cost function that lets you plug in any activity level and get a pretty accurate total cost prediction, within your relevant range, of course.
Okay, let's unpack this. Our sources lay out two foundational estimation methods to tackle this exact problem.
Two main ones, yeah.
We have the approach that emphasizes visual intuition and the entire data set. That's the Scattergraph Method.
Mm-hmm.
And then we have the lightning-fast objective approach that relies on just two extreme points, the high-low method. We'll start with the scattergraph because it provides, I think, the essential context.
I agree. The Scattergraph method is kind of the first step in cost analysis because it gives you a sense of the data's personality. You use every piece of information you have.
The process is straightforward, but the insight is immediate. You plot every single data point, your total cost for a given month, on the vertical axis against the corresponding activity level, maybe direct labor hours on the horizontal.
And you end up with a cluster of historical dots.
Exactly.
And this cluster immediately tells you if your relationship is linear or if your costs are, behaving strangely.
Okay, so then step two is the moment of judgment, right? You visually draw a single straight line through those points, the one you believe best represents the average trend.
And once that line is fitted, the component pieces of our equation, total cost equals fixed cost, plus the variable rate times activity, they're right there for us to harvest.
That's the elegant simplicity of it. The fixed cost component is simply the y-intercept.
Right. That's the point where your visually fitted line hits the cost axis when activity is...
When activity is 0.
Exactly. According to the example data we have, the line starts at $40,000. That's your estimated fixed cost, even if you produced absolutely nothing.
And the variable cost per unit, that's just the slope of that line. We calculate it by picking 2 points on the line and finding the rise over run.
And if we look at the source's visually determined slope, the change in cost was about $30,000, and the corresponding change in activity was 7,000 direct labor hours.
Okay.
Dividing those figures gives us a variable rate of approximately $4.29 per hour.
So based on this visual interpretation of all the data, we have a functional predictive model.
Yeah.
Total cost equals $40,000 plus $4.29 multiplied by direct labor hours. That equation is powerful, but I'm worried about that $4.29 being visually estimated. How do we justify that inherent subjectivity?
That's the primary trade-off. The pro is huge. You use every available data point, so you minimize the risk of one single outlier corrupting your model. But the con is that it relies on judgment. Different analysts, drawing the line slightly differently, will get different fixed costs and, different variable rates. We're trusting the intuition of the analyst, but we sacrifice mathematical exactness for that intuition and context.
So the scattergraph tells us what feels right based on the overall picture.
Yeah.
Now let's pivot to the high-low method, which just throws intuition out the window in favor of pure, quick calculation.
That's a good way to put it. The high-low method is often used when time is short or when you just need a completely objective estimate right away. It strips the entire process down, relying only on two extreme data points.
And this is the critical distinction we have to emphasize. You choose the points based on the activity level, not the total cost. You're looking for the month you were busiest and the month you were slowest.
Exactly. Based on our source data, the highest activity point was May, clocking in at 18,000 hours with a corresponding $120,000 cost.
Okay, that's the high point.
And the lowest activity point was February, with 6,000 hours and a $60,000 cost. The other 10 months of data are, for this method, completely irrelevant.
Here's where it gets really interesting, because we're going to use those two extremes to calculate the variable rate, forcing them to define the slope of the line. It's almost like pulling a tight string between the two farthest fence posts.
Yeah. We calculate the change in cost, that's the rise, divided by the change in activity, the run. This gives us the variable cost per unit.
Let's run the numbers quickly. The cost difference, the rise, is $120,000 minus $60,000, which is 60,000 hours.
Right.
The activity difference, the run, is 18,000 hours minus 6,000 hours, giving us 12,000 hours.
So,
Therefore, $60,000 divided by 12,000 hours delivers a very clean variable cost of $5 per hour.
that speed is just unmatched. Now, to find the fixed cost, we simply take that $5 variable rate and mathematically isolate the fixed portion using one of our data points.
Okay, let's use that high point in May again. We know the total cost was $120,000. So if we take our $5 variable rate times the 18,000 hours, that accounts for $90,000 in variable costs.
And subtracting that variable cost from the total cost, $120,000 minus $90,000 leaves us with a fixed cost of $30,000.
Simple as that.
And the advantage of this being an objective mathematical method is that if you run the calculation using the low point, you get the exact same $30,000 result. It checks out.
So the resulting cost equation for the high-low method is total cost equals $30,000 plus $5 multiplied by direct labor hours. That was undeniably fast and clean. But isn't the whole point of cost analysis to deal with the entirety of the cost behavior?
Well, yes.
By ignoring 10 months of data, aren't we running a huge risk that one of those 2 points, the high or the low, was a massive outlier that skews the entire cost model?
That is the essential flaw and the major criticism of the high-low method. It's simple, it's fast, and it's objective. Those are huge benefits. But if May happened to be a month where a machine broke down and generated massive atypical repair costs, or if February was artificially low because of some unexpected shutdown, those outlier costs will define your entire predictive equation.
So you're essentially defining your normal cost behavior based on two potentially abnormal events.
Exactly.
It's like drawing a straight line between the two most bizarre months and calling it average.
Correct. The $5 variable rate we derived is perfectly objective for those 2 months, but it may be completely unrepresentative of the, the $4.29 rate the Scattergraph suggested for the broader range of activity.
Which brings us to the crucial managerial step, comparison.
Yes.
Let's bring those two methods into direct confrontation. We have a comparison table right here in the sources, and it highlights two fundamental sort of philosophical differences.
The first is the data used. The Scattergraph uses all available historical data, giving it high contextual relevance. The high-low method uses only the high and low activity points. It prioritizes speed over completeness.
And the second is objectivity. High-low is purely objective. Anyone doing the calculation gets $5 and $30,000. The Scattergraph is objective. It requires human judgment to fit the line, making the numbers less mathematically certain.
And here is the crucial insight that you, the listener, must internalize. Both methods produce estimates. They're models of reality, not reality itself.
Right.
Let's see what happens when we try to forecast a specific standard activity level, say exactly 10,000 hours, using both of our new equations.
Okay. Based on the Scattergraph equation, we take the $40,000 fixed cost and add $4.29 multiplied by 10,000 hours. That predicts a total cost of $82,900.
Now, compare that to the high-low equation. We take the $30,000 fixed cost and add $5 multiplied by 10,000 hours. That predicts a total cost of $80,000.
That's a $2,900 difference in the estimated total cost. At the exact same activity level, that's a significant variance.
It is.
For a manager, why should I care about a $2,900 difference in an $80,000 budget?
You care because that $2,900 is the difference between making an accurate short-term pricing decision or not. You care because it affects your budget variance analysis.
That's so.
Well, if you budget for $80,000, but the true cost behavior suggests $82,900, you are going to report an unfavorable variance, and you won't know if that's due to bad operations or just a bad original forecast.
So the $2,900 difference essentially defines the uncertainty. It's the margin of error in our quick estimates. What would make a manager choose the high-low estimate over the Scattergraph one?
Speed is number one. If you need a quick, justifiable figure for a scenario analysis today, high-low delivers.
Okay.
Secondly, you'd favor high-low if you were supremely confident that your high and low activity points represented normal, efficient operations. Conversely, you'd favor the scattergraph if you looked at your plotted data and clearly saw that the highest activity point looked suspiciously high, signaling a likely outlier.
I see. The scattergraph, by using all the data, it tends to average out those extremes, creating a shallower slope, the $4.29 variable rate. Whereas the high-low method creates a steeper slope, the $5 rate,
Yep.
because it's pulled harder by that maximum historical point.
That's the key analytical distinction. They are both trying to achieve the same result, creating a simple, linear cost function. But the scattergraph seeks the line of best visual fit across all points, while high-low forces a line through the extreme points.
And zooming back out, this decomposition is the engine that drives business planning, right?
Absolutely.
By having these cost functions, even if they are just estimates, what can the manager now confidently do that they couldn't before?
Everything related to CVP. They can perform crucial break-even analysis to find exactly how much volume they need to sell just to cover fixed costs. They can model different scenarios. What if we cut fixed costs by $5,000? How does our break-even point drop? And the result is immediate, actionable knowledge.
It allows for incredibly targeted decision-making. Whether it's pricing a new product line or deciding whether to automate a manufacturing step, you know exactly which costs are truly dynamic and which are just locked in.
The ultimate goal isn't the pursuit of mathematical perfection with the first calculation. It's to gain a much better understanding of cost behavior for effective decision-making.
Right.
Knowing that your variable cost is somewhere between $4.29 and $5 gives you a confidence interval you didn't have when the cost was just mixed. Knowledge is most valuable when you can understand it and apply it.
And that confidence check is built right in. If these two simple methods, despite their philosophical differences, yield results that are reasonably similar, like the $2,900 difference we saw here, it dramatically increases your faith that you are operating in a predictable cost environment.
Precisely. And that leads to the final provocative thought. If we connect this to the bigger picture, you should always ask, what happens when these two simple methods yield wildly different results?
What if the scattergraph predicts $80,000, but the high-low method predicts, say, $100,000?
That's a $20,000 difference.
Yeah.
That is the definitive signal that your underlying data is messy, nonlinear, or that your high and low activity points are pathological outliers. This raises a critical question. When the high-low number and the scattergraph line refuse to agree, when is it time to abandon these quick methods and move to more sophisticated tools like true statistical regression analysis?
That's the alarm bell.
That's the alarm bell telling you to investigate the underlying cost drivers further before making a million-dollar decision.
Fantastic deep dive into the fundamentals of cost analysis and the crucial trade-offs managers face every day. That's all the time we have for today. Thank you for joining us.